welcome to this video where I'm going to demonstrate how a reflected cross-site scripting vulnerability works in the then vulnerable web application, also known as the DVWA. And I will demonstrate this across the low, medium, and high security level. So let's begin. So let's start with the lowest security level. And before trying anything malicious, I just want to see how the application handles normal input. So I will just type hello. So as you can see, it's reflected directly on the page, and that tells us that the user input is included in the response. And if it's not properly escaped, that could lead to XSS. And let's check the source code. So here the application takes input from the URL and directly prints it into the page with no escaping at all. And that means that the browser might treat our input as a code, not just text. So now I will try a simple payload. So yeah, so this is just a basic script tag to see if the JavaScript is executed and submit. And there it is, the alert pops up, and this confirms that the JavaScript is being executed in the browser. And in a real attack, this could be used to steal cookies, modify the page, or act as the user. So let's move on to medium security level. Set that to medium and go to the module. So let's check the source code again. So here the application tries to filter input. So it removes the exact string with the script tag, but this is a very weak defense, though it's case sensitive and only blocks one exact pattern. And since the filter blocks lowercase script tags, I will use mixed casing to bypass it. And I will show you how my payload will look. So it looks like this now. And let's try that. So, and it still works, and that's because the HTML is case insensitive, but the filter is not. So this completely bypasses the protection, and this shows why blacklist filtering doesn't really work, where you can almost always get around it with just small change. So let's move on to the highest security level. So and let's check the source code. So this time the application uses regex. So it tries to detect script-like patterns in a smarter way. But instead of trying to bypass this directly, I will change the technique. Because XSS isn't just only about script tags. You can also execute JavaScript through HTML attributes. So instead of using script tags, I will use an event handler since those are often not filtered. So I will use a new payload for this. And it looks like that. So this payload triggers the onError event, and that executes the JavaScript. And as you can see, we now get the cookie here also. So even at the highest level, XSS is still possible because the core problem haven't been fixed. The input is still not properly encoded. And yeah, let's take this a step further. So instead of just showing an alert, I actually steal the session. So first I will start a simple server on my machine. And I will use a new payload that sends the victim's cookie to my browser. And it looks like this. Yeah, you can't see it all maybe, but it looks like that. So let's try that. And check the terminal. So here you can see that the request is coming in with an encoded value in the URL. And I will copy that value. So it's this. And now I will decode it. So I will do that with this command. So I will simply paste in the value here. So, and here we get the original session cookie. So this is the session ID used to authenticate the user. And base 64 isn't encryption, it's just encoding. So it's very easy to reverse, which means if I reuse this session ID, I can impersonate the victim. And that is called session hijacking. So with that said, as you can see, XSS is still not just about popping alerts. It can lead to full account compromise. And across all security levels, the core issue is the same, where user input is inserted into the page without proper encoding. So that was all for me. Bye.